It was Bill Nye the Science.
I just
I never watched him. My neighbors just saying about him all the time.
You never seen Bill Nye?
I don't know.
She didn't study for something. Hi, Dad.
Hey, Sarah.
Hi, guys.
Hi, Sarah. Should you have coffee this morning?
No.
Sugar cereal?
No, I didn't.
Just, you
It
know,
was normal. I just got
jittering.
hardly any sleep, so I'm running on no sleep.
Why were you up so late? Normally when I get no sleep,
I don't know.
I have to have coffee.
I never have coffee.
Who's that waffles mix? Is it you?
Oh no, that was me last
you.
year.
Waffles.
Don't give them
Oh, you don't remember oatmeal and sage? Me and her later.
My mom printed up that recipe for you and I left it on the table.
Oh, yeah. Okay, I'm just gonna photocopy my
Where am I
thing
doing
because I
that?
have one of these.
Yeah. I don't remember what happened. I just remember you were
That's
in.
cool.
I left it on the table.
Would you mind moving the camera again?
Yeah.
Thank you.
Bill Nye the Science Guy.
He almost came to Fort Wayne.
I don't remember. He was on.
Are you running on coffee?
No, I'm always running on coffee.
How are you, Hannah?
Great.
Yeah. Yes.
I slept an hour later.
Oh, okay. Yes.
Okay, I wasn't sure if you were required to take it or not. I don't know. I know there are some people. Okay. I don't think my mom said she can pick us up at
I
4.
don't know, I'm asking you.
She
We
thinks.
have rehearsals,
But
snow and flowers.
I think you guys are taking us almost Thursday. But we're totally fine with staying for the extra class if that's what you
But I don't know.
Okay.
Wait, are you taking open class?
Not today.
Yeah. No, I don't usually stay on Thursdays. I just take the extra class on Tuesdays, and I'm going out to eat tomorrow. And I was like, I need to burn off some calories so I can eat some calories. Yes.
Yeah, we didn't know.
You probably
I
got
don't think that first thing I was like, wait.
all the true false.
What's that from?
You know,
Oh my
I
gosh,
leave
no.
this right here
You'll be
because it's so
the one
beautiful. As far as I people don't even look at it.
Oh my god.
I put it for a normal clip, so it's like,
I told you.
There you go.
Yeah,
This is the best thing I've ever seen.
I don't know.
I already
used
finished
to
off my
like it.
history notebook.
I've used
Give
so
him a
much.
back.
I've used half.
And your notebook's tiny.
Interesting lines.
Oh my gosh, you're flying.
Oh, yeah.
I only do like
Yeah.
I was expecting to have to write more, so I spaced it out, and then I was like,
Wait, do you
I write
do
my
my
notes in here and I do my homework.
Do you do? Oh, you don't use this.
I thought we were gonna have to like write stuff, so I took space, and then we didn't. So.
Oh my god, it was so much space.
Back to your homework. Yeah, go ahead and get out your notes. Today we're gonna start talking about triangles. I'll let you guys write and then I'll talk.
New screen.
No. Sorry.
Thank you.
Okay, so a triangle, the geometry definition of a triangle is the union, of three segments determined by three non-collinear points. That's only underlined because it thinks it's not a word, but it really is a word, so FYI. And if we have 3 points on the triangle, R, S, and T, those are called the vertices, or singular vertices would be a vertex. So R is a vertex, S is a vertex, and T is a vertex of the triangle. The sides are line segments, and there are 3 sides. So 3 line segments formed there by the 3 vertices, R, S, ST, and RT. And then there are also 3 angles, angle R, angle S, and angle T. We can classify triangles in a couple different ways. The first way we can classify triangles is according to their side lengths. A scalene triangle has no sides that are congruent. So, yeah, none of those look congruent. I always have the hardest time drawing scalene triangles. An isosceles triangle has at least 2 sides congruent. And to mark congruent sides, we use little tick marks, I guess. And an equilateral triangle will have all 3 sides congruent. So technically, an equilateral triangle is also isosceles, because isosceles triangles are at least 2 sides that are congruent. So an equilateral triangle is also isosceles. And we can also classify triangles according to their angles. So if all three angles of the triangle are acute angles, we call it an acute triangle. If there is one angle that is obtuse, we call it an obtuse triangle. If one angle is the right angle, we call it a right triangle. And if all the angles are congruent, we call it equiangular. So, to refresh our memory, what is an acute angle? Good, an angle that's less than 90 degrees. And an obtuse angle, Aaron?
Over 90 degrees.
Good, greater than 90 degrees. And a right angle is 90 degrees. Good, good. So an acute triangle will, most normal triangles are acute triangles. So they are, all of their measures are less than 90. Sometimes we have an obtuse triangle where one of the angles, these are very pretty pictures. One of these angles is obtuse. A right triangle will have one angle that is a right angle. And an equiangular triangle will have all of its angles congruent. And that's how we show congruent angles. An equiangular triangle would also be an acute triangle because all of the angles would be less than 90. Sorry, thanks. Okay. We also have something called an exterior angle of a triangle, which is easier to draw than to give the definition of. Let's see what your book says for exterior angle. Yeah, we're not writing that down. We're just gonna draw a picture. Because it won't make any sense. Alright, so an exterior angle of a triangle is on the outside of the triangle. So here, if we have A, B, C, D, the exterior angle is going to be this angle right here. What would the name of that angle be? Paige?
Angle CBD.
Yes. So an exterior angle is like that. You can't really see that very good, can you? Angle CBD. So it's not inside the triangle, it's not part of the triangle, but it's formed by one side of the triangle and then one side that's extended to form a line. Your book says if BD is opposite to BA, then angle CBD is called an exterior angle of triangle ABC. And then, sorry, I didn't plan this as well as the rest. Angle. And then with that same picture, we also have something called a remote interior angles. The remote interior angles are the two angles in the triangle that are not adjacent to angle CBD. So remote, meaning they're farther away, like remote, like out in the distance. So the two remote angles here are this angle and this angle, because those are the two angles of the triangle that are not adjacent to the exterior angle. And what can we call those? We can just call them angle A and angle C because there are no other angles coming off of those points, so we don't need to use 3 letters to name them. Right. Does everyone see why angle ABC is not the remote angle? Because that is the one that's touching the exterior angle, so that one's not it. Okay? So if you have an exterior angle, there's 2 remote angles that go along with it inside the triangle. Okay? Alright, and then we have a theorem. Theorem 3.7. This is going to come into play a lot. The sum of the measures of the angles of a triangle, anybody know, is,
180.
180, yes. 180. So in every single triangle ever, if you measure each of the angles and add them together, it will always equal 180 degrees. Okay, and we have some corollaries to that, and I don't think we've talked about corollaries before. A corollary can be used as a reason and a proof, just like theorems, postulates, and definitions. And in your book, the definition of a corollary is a statement which can be proved easily by applying a theorem. So it's not a theorem, it's not a postulate, but it could be easily proved by applying the theorem. And so there are 4 corollaries that go along with theorem 3.7. First, we have if 2 angles of one triangle are congruent to 2 angles of another triangle, the third angles are congruent. The second one is that each angle of an equiangular triangle has a measure of 60. Does that make sense? How did they come up with 60? Hannah?
Because 3 angles of the measure 60 equals 180, and 180 is a triangle.
Right, so if we have an equiangular triangle, that means all 3 angles are equal. If the total measures of the angles are 180, then if we divide that by 3, each one would be 60. So that can be easily proved from theorem 3.7. Corollary 3 is in a triangle, there can be at most one right angle or obtuse angle. Why would that be? Yeah,
Because at a right angle, the biggest angle would be 90, and then the two others would be 45. And then an obtuse, because it's so big and it has the biggest measure, then both of the other angles would be acute.
right, because if I add two 90s together, if I add 90 plus 90, where am I at?
Over 100.
Well, if it was 90, I'd be exactly at 180, and I still have to have another angle. So there's no way there could be another angle, because they have to add the equal 180. Same thing with obtuse. If I have anything bigger than 90, 91, or anything bigger than that, and I try to add another obtuse angle 91, I'm already over 180 degrees, so that doesn't work. And the last corollary is the acute angles of a right triangle are complementary. Meaning what? Page?
They're going to add up to equal 90 plus 0 times 90 plus 90 equal 180.
Right. Very good. So complementary means they add to the 90. So if we have a right triangle, we have one angle that's 90, and we know total they have to be 180, so then the other two angles must add up to be 90 to equal 180 total for the triangle. Okay? Good. And there's one more theorem, 3.8. There's a lot of information here, which says that the measure of an exterior angle of a triangle is equal to the sum of the measures of the two remote interior angles. So let's draw a picture for that one. Okay, so again, let's just call it A, B, C. And we can just put a number for this angle, we'll just call it angle 1. Okay, so this means that, can anybody write an equation for that? Want to take a stab? Natalie?
So like angle A and angle B equal,
Let's say the measure.
oh, the measure of angle A plus the measure of angle B equal the measure of angle 1.
Good. Yes. Right. So A and B are the remote interior angles. They're the ones that are not touching the exterior angle. If we add those together, that will equal the measure of angle 1. Would anyone like to speculate as to why that is? Madeline?
Because, like, I had it in my mind, but I
That's
forgot.
okay. We'll see.
Because like the C, angle 1 and like the angle C, they're like they equal 180, and then so A and B and C equal 180, so that means that A and B and 1 are equivalent. Does that make sense?
Okay, very good. I think you're definitely on the right track. I mean, I think you get it, but I don't know if everybody else could understand what you said. Mac?
Angle 1 is obtuse. So, if the whole triangle equals 180, then angle A and angle B have to be smaller than obtuse to equal 180 with an obtuse angle. So when we add together, And yeah. I don't know.
Okay, good. Madeline?
I got it back.
Okay, you got
Okay,
that.
so angle 1 and angle C have to equal 180. And then angle C and angle A and angle B have to equal 180. And so if angle C equals something, then angle A and angle B have to equal the same thing as angle 1. Otherwise, it wouldn't work. Because,
Good, and that's what Wolfie was saying
Yeah.
before, okay? Good, so 1 and 2 are adjacent angles, so they're supplementary. So 1 plus 2 will equal 180 degrees. Also, we know, I technically should be saying the measure here, the measure. You don't have to write this down, I'm just trying to explain to you why this is the case. So, also, the measure of angle A plus the measure of angle B plus the measure of angle 2, we're calling it, since there's 2 angles at C, will also equal 180. So therefore, if I subtract angle 2 from, or if I substitute, say, measure of angle A and B could be substituted for the measure of angle 1. In other words, they will be equal, right? Does that make sense? The proof for that is actually in your book if you are interested in seeing it. I'm going to tell you your assignment now in case we run out of time. We're going to do oral exercises until the bell rings. But your assignment is going to be page 100, numbers 1 through 16. And if you want to right now, look at page 99. Let's go through some of the oral exercises. Okay, true or false again. Your assignment is not that way though. Number 1, all equilateral triangles are isosceles triangles. True, right? Because we said that isosceles is 2 or more and equilateral is all 3. Number 2, some scalene triangles are isosceles triangles. False. Scalene has no sides congruent. 3, the union of any 3 segments is a triangle.
true.
That one is false. What would be the exception there? Or why would it be false? Connie?
Because they have to be non-collinear.
Right, very good. They have to be non-collinear, very good. Number 4, a triangle may have 2 obtuse angles. False. Number 5, every equilateral triangle is an acute triangle. True. Number 6, if one angle of a triangle has a measure of 90, then the other angles of the triangle are acute angles. True. Number 7, each vertex of a triangle lies in the interior of the triangle.
False.
Yeah, that is false. We didn't talk about the interior, exterior very much. The interior is everything on the inside, the exterior is everything on the outside, but there's also the triangle.